Very good morning to everyone. This is Partho sir. In the last class, we have discussed about the various spring and mass system, and we have also found out how to calculate the time period in case of the reduced mass system. Now, in extension to it, we will just chalk out few figures and how to calculate the time period when the spring as well as mass and pulley system are attached to it. So let's first consider the case 1 with a figure. First we are considering there is a pulley, and that particular pulley is fixed in nature, two string attached on the side of the pulley. Now one side there is a spring attached with the pulley, and another side there is a block of mass M attached to it. Now in a very initial stage, as for the free body, we know the tension in both the string will be same. So if the tension in the right hand string is T, left hand string also will be T. Now what we will do, from the free body diagram we can say that mg is equal to T for that particular pulley, and that also we can say in the other way that as it is T, so if there is a tension in this way, so this particular spring constant of the spring is K, so obviously there will be certain extension will take place in this particular spring. So instead of this, certain extension will take place, so it will be elongated bit more. So suppose this elongation is delta L, so we can say K into delta L is equal to T is equal to mg. That is our equation number 1. Now what will happen if we push that particular block with an external force F? Then we can say, as per the free body diagram, as per FBD, the free body diagram of this block will be F is equal to mg minus K into delta L plus X, and that will be equal to minus Kx, because as we know this mg and K into delta L, these are same. So we can say mg minus K into delta L minus K into X, this will be strike out, so ultimately it becomes minus K into X. So this is the scenario of the first block. As the body here, that particular body means the body M executes an SHM. So if it's execute an SHM, so we can say that the angular frequency, this angular frequency will be equal to omega, and that will be equal to root over of K by M. So time period will be obviously 2 pi root over of M by K in this particular case, because omega is equal to, we can write down 2 pi by T, and that is equal to root over K by M. So this ultimately goes to there, and we can find out the time period of this particular system. Now we are coming down to the next case, that is case 2. In the case 2, we will draw the figure in bit different manner. For example, suppose there was a spring attached vertically with a particular pulley, and one mass is attached over here, that mass M, and that particular string goes straight downwards. Now in that case, the spring constant is K, and the pulley is absolutely fixed and massless. So here the tension will be T, because as the pulley is fixed and massless, so tension will be T in both the string. Now what will happen in that particular case? If we see that T is equal to mg, that is the initial first stage, that is the equation number 1. and 2t is equal to k into delta L. That means delta L is the extension of that particular string, not spring but the string. So we can say 2 into mg, because here we have seen t is equal to mg. So if we put that value over here, that will become 2 mg. So 2 mg is equal to k into delta L. So we can say mg is equal to k into delta L by 2. So that is our equation number 2. And now from this particular 2 equation, we can say once the body is stretched, so in that case 2t dash is equal to k into delta L plus x by 2, because this way here the displacement will be x by 2 if the displacement here is x. So now this equation number 3. So we can find out the equation like mg minus t dash, because ultimately it is be t dash, that equal to mg minus half into k into delta L plus x by 2. So here we'll see 0 minus k into x by 4, that is the ultimate, so it will be kx by 4. So we can say omega is equal to root over of k by 4 by m. So we know omega is equal to 2 pi by t. So we can put this equation in this form and we can easily find out the time period, that will be 4 pi into root over of m by k. So this will be the time period once the pulley is attached in this manner. Thank you very much.